Okay, so in this video we're just going to go through another example of finding f at t given f at s. So we have f at s is equal to 3s plus 10 over s plus 3 times s squared plus 16. Uh, so again here we are going to be splitting this into parts. And now because this here is a linear term, we get a over s plus 3. But then this here is, remember what we call this, is an irreducible quadratic. And in this one we're not going to do the complete the square, and I'll show you why in a second. This would be, we'd have plus a bs plus c over s squared plus 16. Alright, so again, what you want to do as far as when you're doing these Laplace transforms, you want to keep the table in hand here to kind of know where you want to go for. So remember on the previous example here, we did a complete the square so we could get it in the form of s plus a quantity squared plus omega squared. And then we did all of the things and found, our coefficients. But in this case, we have it in the form of s squared plus 16. So it's really not in a form to do any kind of complete the square. And if I look here for the sine and cosine, look, that's s squared plus omega squared. So we have s squared, and then 16, of course, would be omega squared, so omega would just be 4. So we're definitely going to get some kind of sine or cosine coming out of this here. Alright, so that's what we really kind of need to think about here. Is like, okay, well, what forms am I going to get? Because that's going to kind of guide me on how I'm doing my partial fraction expansion. Alright, so we have it set up like that. And then, of course, we would multiply through by my denominator to get 3s plus 10 is equal to a times s squared plus 16 plus sorry, just spaced here for a second, bs plus c times s plus 4. And then again, we're going to, pick smart numbers. And the first one I would say would be a smart number to pick would be s is equal to negative 4, because clearly that's going to kill both the bs and the c. And so if I do that, I would have 3 times negative 4 plus 10 is equal to a times quantity negative 4 squared plus 16. And so if we do the arithmetic here, you'd get negative 2 is equal to 36a. And so a is equal to negative 1 over 18. Alright, now there's several ways you could approach picking other smart numbers here. Again, kind of with what we did in the previous example here, another smart number would be to pick, since I already know what a is, picking s equals 0, because s equals 0 is going to kill the b term. And so if I pick that, I'd have 3 times 0 plus 10 is equal to, well, a is negative 1 over 18, 0 squared plus 16, plus 0 times s plus c times 0 plus 4. And again, now I look at this, I've just got a bunch of arithmetic I have to do. So you have 10 is equal to negative 16 over 18 plus 4c. Now, I just made this problem up randomly, so the numbers aren't going to necessarily be, quote, very pretty, but that's fine. We can still deal with this. And let's see here if I can do this arithmetic here. So let's see, we'd have 10 is equal to negative 8 over 9 plus 4c. And then doing the arithmetic, that would be 90. So we'd get 98 over 9 plus 4c. And then we'd get c, dividing everything by 4. We'd get c here. Let's see here. 98 divided by 4. math is failing me right now, would be 49. So we'd get 49 over 18. And of course we can double check that on the calculator, and you probably want to double check my arithmetic just to be safe. In fact, I'm going to pause the video and double check my arithmetic right now. And yeah, when I double check my arithmetic on my calculator, I got 49 over 18. Alright, so we have one left to go here, and that's to figure out what B is. But at this point here, since we know what A and C are, we can pick any convenient number for that we haven't used for S to figure out what it is. Now, often when I'm at this point, I just use S equals 1. Sometimes you could say, oh, well, maybe it would be better to use like S equals 2 or something like that. And the only reason it might be better than that is you might get nice even numbers, but I often just use S equals 1 as long as I haven't already used it. If I've already used S equals 1, I have to use, of course, something else. So, but let's go ahead and do S equals 1 here. So we have S equals 1. I'll do it in a different color. And just making sure I'm going to leave it so I can at least write this first line down here. So this would be 3 times 1 plus 10 is equal to, again, negative 1 over 18. 1 squared, of course, is just 1 plus 16 plus, and then this would be B plus 49 over 18 times 1 plus 4. And then again, we just need to kind of multiply everything out, combine terms here. And so we'd wind up with 13 is equal to negative 17 over 18 plus 5b plus 245 over 18. And then I'll just use my calculator real quickly to solve this. So I'm not going to show the work. This is obviously something that's pretty simple at this point. We should all be able to do this. Minus 245 over 18, and then divide that by 5. And I get here that B is equal to 1 over 15. And so I'm going to go ahead and pause again just to double check my arithmetic. Yeah, so I got the same answer again here. And so now what we can do here is we can now write my partial fraction expansion here. We can say that f at s, I'm going to need to kind of scroll up and down here a little bit, is equal to negative 1 over 18 times 1 over s plus 3 plus b is 1 over 15, so I'll have 1 over 15 times s plus 49 over 18, and this is all over s squared plus 16. Now, this is where we need to, again, kind of look at the Laplace transform table and see what the forms are that we need to get these in order to make this correct. So, pulling up the Laplace transform table, the first one, of course, is easy. The 1 over s plus a, so we would have, of course, e to the negative 3t. That's one that you're going to just come familiar with because it pops up all the time. The sine and cosine one, it's not that they're difficult, but we have to look at this a little carefully. It needs to be in the form of just s over s squared plus omega squared, and then just omega over s squared plus omega squared. So let's see how we're going to do that here. So I'm going to first do a little bit more here. So I'm going to say this is negative 1 over 18 times 1 over s plus 3, and then I'd have plus 1 over 15s over s squared plus 16 plus 49 over 18 over s squared plus 16. So why am I doing that? Well, I'm breaking the s and the constant apart because if I look at my Laplace transform table, the cosine has just an s in the numerator, and the sine has just an omega in the numerator. So if I think about this here, if I look here, I'm just circling that portion right here, this is cosine of 4t if I do the inverse Laplace transform of that. So that one were really good, and so I just would have a 1 over 15 sitting out in front of it. Well, that's easy enough to do. But then if I look at this one here, I was like, well, wait a minute, what do I have here? Well, this one looks a little bit more challenging. It's not too bad in the end, but what do we have here? Well, we need it in the form of omega, I'm going to write it off to the side here, over s squared plus omega squared. So we need it to look like 4 over s squared plus 16. Well, how do we make it look like 4? Well, same kind of thing we did in the previous example. I need a 4 there, so I'm going to multiply by 4 and then divide by 4. And so what I'd end up having, let's rewrite this line down here, is I'd have f at s is equal to negative 1 over 18 times 1 over s plus 3 plus 1 over 15 times s over s squared plus 16. And then I'll have plus, I'm going to pull that 49 over 18 out in front, and then I'd divide by that 4, so I'd have multiplying by 1 over 4, and then I'd have 4 over s squared plus 16. But then again, if we look at these here, this is e to the minus 3t. This one here is cosine of 4t. And then this one right here is sine of 4t. Now all we have to do is do the arithmetic out here and get the numbers to work out. And so in the end what we'd have here is that f at t would be negative 1 over 18 e to the minus 3t plus 1 over 15 cosine of 4t. And then if you do the arithmetic, you'd have plus 49 over 72 sine of 4t. And then remember, to be technically correct when we do these, and you can even see in the Laplace transform tables, they often don't include that because sometimes it's just automatically assumed that when you're doing Laplace transform, the time domain is automatically restricted to t greater than 0. But sometimes, and I think it's a good habit to get into, we emphasize that by multiplying by the step function so that we understand this is only for time greater than 0. And so that's how we have to do there. So again, if you look back at the original problem, it's already factored for us, and we just have to do the partial fraction expansion. So it's really just a little bit of algebra and a bit of arithmetic. And then the only thing I wouldn't say it's tricky, but the only thing you have to think about then is when you get to this step here, when you get to kind of in here, you have to make it in the forms of the Laplace transform table. So that's why it's always good to have this table sitting next to you. And then of course, remind you that any exams that we will have in this course, I will provide the tables for the Laplace transforms. That will be something you'll just be given. I don't expect you to have these memorized, although as you use these more and more, you'll naturally memorize some of them, especially the top 3 here. You'll memorize what the Laplace transform of the delta, u of t, and e to minus at is. I mean, that's just going to happen naturally because they appear so often. Okay, so we'll end this video here.